Good day, class. In this video, I will teach you the easiest method of solving the inverse kinematics for a given mechanical manipulator. Okay, so this method is the graphical method. The graphical method makes use of the Pythagorean theorem, SOHCAHTOA, and law of cosines. So this is a review and applications of those what you have learned from your trigonometric subjects. Okay? So take note only, class, that you can only use graphical method if your kinematic diagram has a simple design. Okay, again, you can only use graphical method if your mechanical manipulator or your kinematic diagram has a simple design. So example of kinematic diagram or mechanical manipulator that has simple designs are 3 degrees of freedom, Cartesian manipulator, 3 degrees of freedom, articulated manipulator, 3 degrees of freedom, spherical manipulator, 3 degrees of freedom, cylindrical manipulator, and 3 degrees of freedom, Scara manipulator. And for our example, in this lecture, is our 2 degrees of freedom, okay, R&R manipulator, R&R special manipulator. Okay? So the first step of graphical method, okay, for our simple mechanical manipulator is to first draw the kinematic diagram, of course, and make use only of the base frame. Okay? Make use only of the base frame. You will not use the other frames. Okay, you will just use the base frame. Okay, so just leave the link lengths and the joint variables. Okay, so you will need this. In step 2, you will redraw your kinematic diagram. You may redraw your kinematic diagram in front view or in top view. Okay, so it depends on your observation, and it depends also of how you practice. Okay, how you practice answering, or how you practice finding the solution for inverse kinematics for your mechanical manipulator, because your goal here is to find again triangles. Okay, you need to find again triangles for your Pythagorean theorem, SOHCAHTOA, and law of cosines. So you only use Pythagorean theorem and SOHCAHTOA if you have a right triangle. Law of cosines if the sides of your triangle has have no equal are not equal. Okay, if the sides of your triangle are not equal but there is a given angle, okay, opposite to the given side, okay, opposite to a given side. Okay, so you may redraw this manipulator in front view, okay, like this. You may draw this in front view first, or you may draw this at top view first. Okay, at front view, okay, so you will do an analysis of how to find the solution for your inverse kinematics. Okay, so at the front view, this is the end effector, and at the end effector there is the Z02 Z02, okay, Z02 and X02, okay, and X02, X02. Okay, where can you find Z02 and X02? So, the end effector, okay, the distance of the end effector to the ground, okay, the distance of the end effector to the ground is your Z02, okay, is Z02, while your X02, okay, your X02 is your distance from the end effector up to the origin of your base frame. Okay, so this is X02. Okay, but but the mechanical manipulator class is moving, so you will not depend your X02 at the at just the distance of the end effector up to the origin of the frame of the base frame. Okay, you can depend the Z02 to the you can depend the value of Z02 at the distance of the end effector to the ground, because this Z02 is equals to A sub 1 plus A sub 3. Okay, Z02 is equals to A sub 1 plus A sub 3. Okay, so A sub 1, okay, A sub 1 from the base up to the middle of the second joint. Then A sub 3 is from the middle of the second joint uh, this this location, okay, of this link. Okay, so if you add these two, the resulting sum is Z02. Okay, so because of this, you already have the first position vector. Okay, but position vector class is given again at the inverse kinematics. The position vector is given. What you will do is to find the joint variable. Okay, in this solution, Z02 is equals to A sub 1 plus A sub 3. You can't find, or you can't solve a joint variable. Okay, because Z02 is just A sub 1 plus A sub 3. So, even though Z02 is equals to A sub 1 plus A sub 3, it's not helpful in your inverse kinematics solution. Okay, so this is the only analysis you can get from the front view of this kinematic diagram. So let's go to top view. Okay, again, you will draw either you can start from front view or top view, or top view first then front view. It depends on the analysis that you will do. Okay, so let's move X02. Let's go to top view. So I redraw the kinematic diagram at this top view drawing. Okay, so if you notice, class, that I redraw uh, the original kinematic diagram where where it is where the theta 1 and theta 2 looks like they have values. It means they are at they are not at the straight line. Okay, they look like at 45 degrees. Okay, theta 1 look like at 45 degrees, as well as theta 2 is in 45 degrees, but this is not 45 degrees. Okay, this is not 45 degrees. This just looks like 45 degrees. I made it like that so that we can have a triangle. Okay, so again, our goal here is to have a triangle that will give us that will help us to use the Pythagorean theorem, or the SOHCAHTOA, or the law of cosines. Okay, so let's find a triangle. Okay, so let's analyze this kinematic diagram at top view. Okay, so this is the end effector class. This is the end effector. So because this is top view, we can only see the y sub 0 axis and the x sub 0 axis. So y sub 0 axis is pointing upward, so it means that this, okay, it means that this is, okay, this vertical line is the the y02. Okay, this is the y02, while this horizontal line along the x-axis is the x02. Okay, this is x02. Okay, this is x02. So what does this tell to us? We have here two lines, okay, that has a given value. Okay, y02 is given and x02 is given because they are position vectors. Okay, y02 is given, x02 is given because they are position vectors. So it is at the definition of inverse kinematics. Position vector is given, then we will solve for the joint variables. Okay, so what we need to find is the value of theta 1 and theta 2. A sub 2 and a sub 4 is also given. Okay, so we have here a side of y02, a side of x02 that is given. Okay, so we need to find a way that it will give us the answer for theta 1 and theta 2. Okay, so if you look properly, this is a right angle. Okay, so this is a right angle. What we need next is a hypotenuse. Okay, so we need a hypotenuse. So we have here a hypotenuse. This will be your hypotenuse. Okay, so now we have a right triangle. Now that hypotenuse will be named as r sub 1. Okay. That hypotenuse will be named as r sub 1 because it is named now r sub 1, and r sub 1 is not given while y02 and x02 is given. We can use the Pythagorean theorem. Okay, we can use the Pythagorean theorem to solve for our hypotenuse. Why do we need to solve for the hypotenuse? Because as you can see, we also created a triangle here. Okay, a triangle with no equal parts. This one, this, and this. Okay, A2 and A4 is given. This is A2. This is A4. Okay, this is A2. This is A4. This is R1. R1 is not given yet. If we know what is R1, the law of cosines will be easy to use. Okay, so to get the R sub 1, we will use the Pythagorean theorem. So it will look like this. So R1 is equals to square root of x02 squared plus y02 squared. Okay, so let's box our first equation. Okay, next, now we have a value for r sub 1. We can also have a value for the angle down here. Okay, we have an angle down here because this is a right triangle. Of course, there is a there is an angle opposite to y02. Okay, there's an angle opposite to y02. Okay, we will name this angle we will name this angle phi 2. Okay, we will use other symbol. Okay, we will name this angle phi 2. Okay, so inside the angle phi 2, wait a minute. Okay, so inside the angle phi 2, we have theta 1. Okay, and there will be another angle here inside. Okay, that angle will be named as phi 1. Okay, that angle will be named as phi 1. So let's I will name it phi 1. Okay, this is phi 1. It is located here. Okay, this angle is phi 1. Okay, so as you can see, phi 2 is equals to theta 1 plus phi 1. Okay, or it will be theta 1 is equals to phi 2 minus phi 1. Okay, so we solve theta 1 because it is the one what we are need to solve. Okay, this is what we need to solve, theta 1. Okay, so I'll change the color. I'll change it to color pink. Okay, to remind that we are solving for theta 1 and theta 2. Sorry, it should be purple or violet. Okay, so theta 1. Okay, so again, theta 1 came from the difference of phi 2 and phi 1. Okay, phi 2 is the opposite angle of the side y02. Okay, and inside the phi 2 is the angle of theta 1 and phi 1. So we have theta 1 is equals to phi 2 minus phi 1. So let's back this equation. Next, so we don't have yet the value for phi 2. We don't have a value yet for phi1. So what we need to do is to find the value for phi2 and the value for phi1. So we can find the value of phi2 using SOHCAHTOA. Okay, using the tangent formula. Okay, the tangent, it will become tangent phi. Okay, tangent phi is equals to opposite over adjacent. Okay, opposite over adjacent. Or phi2 is equals to V2 is equals to inverse tangent of y02 over x02. Okay, so again, V2 is the opposite angle of our side y02. Y02 is given. Okay, so we can get the value of V2 using SOHCAHTOA, using the tangent formula. Okay, so we will have v2 is equals to inverse tangent y02 over x02. So let's box this formula. Okay, now we have the value of v2. We need the value of phi1 to solve for theta 1. Okay, so phi1 is located here. Okay, phi1 is here. This is phi1. Okay. Opposite phi1 is r sub 1. Okay. Opposite phi1 is r sub 1. And am I right? No. Opposite phi1 is a sub 4. Okay. Opposite phi1 is a sub 4. This link length a sub 4. Okay. So we have already know the sides, the value of each side. We know a sub 4 is given, a sub 2 is given. We can solve r sub 1 using Pythagorean theorem. Okay, so what we need to use now is the law of cosines. Okay, so the law of cosines looks like this, where A is the opposite side of the alpha angle. So if it's the opposite side, we will equate it to the opposite sides. Then we will square it. So it is equals to the uh, uh, sum of the other sides, b squared plus c squared. Then subtracted to 2 times b times the other side, b and c, cosine alpha. So it is called law of cosine because you use the cosine. Okay, you use cosine at your solution. Okay, if this is law of sines, so we will use sine, but we are using cosine instead of sine. You can also use the law of sines, but the law of cosine is much easier to use than the law of sine. Okay, so in this kind of problem, law of cosine is much easier to use. Okay, so because alpha phi is alpha. Okay, so we will have inverse cosine, okay, of the opposite A minus B minus C, and there are all squared over negative 2BC. Okay, so we will do it here. We will have this equation to solve for phi1. Okay, so because this is the formula of solving phi1, we will square it. We will put it inside a square. Okay, or inside a box, or inside of a rectangle. Okay, so we need to put some numbering so that we will not be confused of how the computation okay, comes out. So we need to know what will comes first and the next computation, so that we could get what we want at these equations or these formulas. Okay, so I am numbering the first one. Okay, the first one you will do is the r sub 1. The r sub 1 equals the Pythagorean theorem. The number 2 is the tangent formula. Then after the tangent formula is the cosine formula. Okay? So that you could get the phi2 and phi1. So you can subtract them to each other and you can get the theta 1. Okay? So now you have now theta 1 using this equation or solution. Okay? So next we have now we have theta 1, we need to have theta 2. Okay? To solve for theta 2, we will use this triangle of R1, A2, and A4, because A2, A4 is given already. R1 is we can solve for R1. Okay, so we will use this triangle again because most of its given are already most of the inputs are already given, okay, and solvable. So to use this, okay, we will analyze our theta 2. So at this side of the angle or triangle, okay, this is the part of theta 2, while the angle outside of it is this. Okay, we can name that phi 3. Okay, we can name that phi 3. This phi 3 and this theta 2 is equals to 180 degrees. Okay, this phi 3 and theta 2 is equals to 180 degrees because we have here a straight line. This link A2 and this imaginary line, where link A4 is where link A4 originally lies. Okay, so theta 2 plus phi 3 is equals to 180 degrees. So it looks like this. Okay. Looks like this. 180 degrees is equals to phi 3 plus theta 2. So we can solve theta 2, okay, by subtracting phi 3 to 180 degrees. Okay, we can solve theta 2 by subtracting phi 3 to 180 degrees. So this is our solution to get theta 2. So let's make theta 2 color indigo. So this is indigo. Okay, let's make it indigo to remind us that we are solving for theta 2. Okay, so to solve this, we need the value of phi 3. We don't know yet what is phi 3. Okay, to get phi 3, okay, we are still inside the triangle of A2, A4, and R sub 1. A4 and A2 is given. R sub 1 is the opposite side of phi 3. So we will use the law of cosine and it will look like this. Okay. It will be look like this. Okay. We will put it inside a rectangle, a black rectangle. Okay. Then we will number it. So after 4, the next one that we will solve is number 5. Okay. Then the last number is number 6. Okay, for our theta 2. Okay. So, using these equations or solutions, we can now solve for theta 1 and theta 2. So, this is the process of graphical method. You will use the kinematic diagram. Okay. Only use the base frame, redraw it into front view or top view, and analyze it. And depending on the analysis of the given joint variables and link lengths, you can uh, you can derive the equations or the solutions to solve for the joint variables. Okay, so this uh, this graphical method requires your understanding again of Pythagorean theorem, Sohcahtoa, and law of cosines, as well as uh, your practice of finding triangles. Okay, finding triangles in a given red drawn kinematic diagram. Okay, so this is graphical method. Okay, so you will solve it in this manner. So this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Okay.